Hey there, welcome to the homework help for Unit 1, Lesson 7. Just a quick recap on the lesson. We worked on identifying the properties and principles of rigid transformation, that there are certain rules that we have to follow with rigid transformation in order to make them work. If we look back at our notes, our lesson summary, this is probably one of the most important pieces of what you could be referring to every single day, what you could be marking up your text. As I go through my video, I would suggest that you mark up this same text as well. Everybody should have the packets that I've made. Endeavor, I'm sorry you don't have yours yet. They are coming to you, but you'll have them there very soon. For the work here, rigid transformation, we need to recognize that it's movement that doesn't change any or change measurements on any figure. That means all of the figures remain congruent. If you have a square that has 3 inches on all sides, then it's still going to be a square that's 3 inches on all sides after any rigid transformation. All corresponding sides, all corresponding angles have to have the same measurement, as I discussed right here in the previous video. Please make sure that you review these summaries every single time. Have them out when you do your homework. On the homework, this will be helpful because we look at these pieces. I have a lot of drawings here to try and make this video quicker. When we look at figure P, the question is saying, is there a rigid motion that takes rhombus P to rhombus Q? The key thing here is rigid transformation, meaning can this figure or do these two figures look exactly alike? Is there any kind of a translation or rotation, of reflection, or a combination of any of them that will make figure P look exactly like figure Q? As I put figure P over top of figure Q, we see that they are definitely not the exact same figure. That answers our question. Is there a rigid transformation that takes rhombus P to rhombus Q? Absolutely not. And the reason for that is because a rigid transformation is a move or any sequence of moves that doesn't change measurements on any figure. And measurements clearly changed here. If you want to have very good vocabulary when you answer that question, look back to right here and look at the things that we marked according to our video. Number 2 talks about triangle A to triangle B. Describe a rigid transformation that takes triangle A to triangle B. Well, this is one that we need to go ahead and go back and look at one of our lesson summaries because quite honestly, folks, we are struggling with writing good descriptions of rigid transformations. We go back to lesson 4. And in lesson 4, we established some things with vocabulary. It was okay in lesson 1 and lesson 2 to be a little bit loose with the vocabulary and not have it right. But now here we are at lesson 7. We have to speak the proper language of transformation. The only moves that happen in transformation is rotation, reflection, translation. Not flip, not turn, not slide, not move, not transition. Only these 3. And as we talk about those 3, they have to be spoken of in very specific directions. As we talk about them, every single translation has to be named its figure that's being moved has to be named, and it has to move from one point to another. We would say that a translation of a certain quadrilateral, in this case over here, moves A to A prime. And by moving that one point, we know underneath rigid transformations that the entire figure is moving at the same rate, which means that it will come to that same position from the pink to this yellow one. And we see that the two figures are exactly the same figure. Nothing has changed on them, but we have to explain that very specifically. Translation of the figure from one point to another. When we describe a rotation, we have to, again, name the figure, tell somebody that's being rotated, and then how it's being rotated, which is very specific. We have to have the magnitude or the measurement for how far it's going to be rotated. We have to tell the person which direction we're rotating the figure, and we have to tell which center everything is connected to and turning around or rotating around. Finally, a reflection. We have to name the figure that is being reflected and across the line M. We can't just say across M or across L. We have to say across line. That way it explains exactly what's being done, because reflections happen across lines, they don't happen across angles or points. Keep in mind, one of the big misconceptions that we've had is under a reflection, that all corresponding points A and A prime, you'll notice that if I complete a little segment across here, that segment and the line of reflection intersect at 90 degrees. This is a perpendicular relationship. Under reflection, that relationship must exist, or else it is not just a reflection. Then it has other rigid motions that are involved. When we look at this one, we have segment BC that's reflected across line M. We see C is here and C prime is here, and we can draw, if you'll notice, just a very light little sketch. I need to think about or imagine that segment between the two being intersected by line M at a 90-degree angle. Likewise with B and B prime. I bring this up because a lot of your homeworks are not living up to the standard of these descriptions. They must be living up to that standard. When we speak the language of math, we understand the language of math. So let's speak it and write it so we can understand it better. That comes back here to number 2. Describe the transformation that has taken place. That description must be very, very clear. That description has to be, I think I lost my little paper. There it is. That description has to tell me, is figure A translating to figure B? Is it rotating to figure B? Or is it reflecting to figure B? We need to have one of those. If it's translating, where is it translating from and where is it translating to? If it's rotating, what is it translating around or rotating around? For how many degrees and in which direction? If we're reflecting, across which line are we reflecting? And where will that figure end? Be very specific in your descriptions, please. Again, refer back to this page for sentence starters to help you to remember how to write those descriptions. Number 3 is just like number 1. I would just say, look at these two figures and ask yourself a question: are these two figures congruent? If they're not, then there's no rigid transformation. If there are, then there is. Make sure to look back at this lesson summary for lesson 7 to help you explain what the rules are for a rigid transformation. Finally, with the last problem here, you are to translate these figures, rotate these figures, so you're going to transform these figures according to the directions that are given. This first one right here, 4A, talks about a translation from A to A prime. Well, that translation, we want to make sure that we get along the straight line or along the right path, but we have to make sure that the figure is lined up correctly. Something that will help us is to draw a vector that connects A to A prime, and on that vector we can put a little arrow because that symbolizes the direction that we're supposed to translate the figure. Apologize, that's kind of hard to see, but you get the idea that this little point that's right here, where A is, must stay on this vector for that distance. But not only that, that figure is not allowed to rotate. Under the rules of translation, it is a slide without turning. So we see these pieces. One way we can make sure that we understand if we're translating correctly is that the pre-image and then the image have parallel lines that pass through corresponding parts of the figure. So these ones right here, this is vertical, this one is vertical. That's a really good spot for us to look to make sure that that happens. The next problem right here, problem B, or 4B, talks about a rotation of 180 degrees. My suggestion with the 180 degrees is also called a straight angle. Straight angle is also a straight line. And here's what I recognize. I see that B and this side of the figure is already on a straight line. So if I look at that and I just use this side right here, there's 2 right here, that means that 180 degrees is going to continue right over this way. So I know that my figure, here, let's do this so you can see it. I know that my figure is going to end up, this corresponding side right here is going to end up over here, and this is my 180 degrees around it. So take patty paper, take something, and look and see where is that going to be 180 degrees, where this side corresponds with its side 180 degrees away, and then I draw that figure in its perfect place. Finally, with the reflection, one more piece to this. You'll notice that the line of reflection that I've drawn spans the entire length of this isometric plane, or this isometric grid. The purpose for that is to help me when I reflect across the line of reflection. Sorry, let me move that up, so that I get the positioning of this exactly right. When you flip this over or reflect this over, what you'll notice is that if those lines aren't aligned up, you can tell, and we can see, and then we don't get a good angle with this, or we don't get a good reflection. As I line up the line, the shape will figure out exactly where it goes because it's attached to that line. We need to have a good description of that. Final thing with the homework. When we do the homework, and there's something that you have to have an image to describe what there is, you have to submit that. There's no way around it. Because this class is an online class, you can't say it's written on the paper. Even though you probably did it on paper, you have to submit that to me. That's why we have the options of taking pictures and then loading them up, or I showed you how to use the page marker tool to draw on your screen and then take a screen capture of it and send it that way. One way or another, it has to be done. That means all of those assignments that you've done that way that have poor grades on it, I need you to redo them if you want a better grade so that I can see the work that you've done. Otherwise, I really can't help you. So please go back and fix those. If you're having trouble with getting these things, like getting pictures or whatever it is, please talk to me. If it's a matter of, oh my gosh, I can't use the isometric plane, well, use the drawing tool. And then just go to the homework that's on, or go to the homework page. I'll include the link to this homework, but look at those pieces and draw it right on your screen and then take a screenshot of it and load that. I don't want to see any more pictures that have lined notebook paper. If we're going to be drawing on a graph, it needs to be on a graph paper or on an isometric grid. That way we can have accuracy and precision, and it's easy for me to see that you understand how many units we're moving away and where it's at. It's not that your drawings are poor, it's that we need to use the right tools to be able to show the best job. So with that note, I want you to know that I am very pleased with how hard you're working. I'm very pleased with the product that you're turning out to me and with the pace that we're keeping. You're doing a great job. Please don't give up. Please don't think you're not doing well enough. All of the grades are updated as of this afternoon. If you're missing something, you really are missing something and it needs to get done. Please reach out to me with any questions on how to get those things caught up. And email is probably the best bet, but you guys are doing great. Know that. Stay the course. Keep doing great things. Stay strong. You're doing wonderful. I'll catch you on the next lesson.